If c and d are positive integers and m is the greatest common factor of those integers c and d, then m must be the greatest common factor of c, and which of the following integers? Don't panic, let's just start somewhere. Let's start by using numbers, plugging in numbers that are within the constraints of the problem. C and D are positive integers. So let's go ahead and say that, C is 9 and D is 3. M is the greatest common factor. Let's go ahead and name that. M, the greatest common factor of 9 and 3, the numbers we've chosen, is just going to be 3. Again, greatest common factor, that is the number that divides nicely into both of these numbers. Then M, read 3, must be the greatest common factor of C, read 9, and which of the following integers? We have C plus D, 2 plus D, and a few more. Well, within the version of the problem that we have made with the numbers we've come up with, let's come up with what these integers are, C plus D. That's 9 plus 3, isn't it? So 12. What is the greatest common factor of this integer, 12, and C, 9? Answer, 3. 3 is the number, the largest number that divides evenly into 12 and 9. You get 6 and 3, respectively. That means that this is a possibility because we were looking for the one that gets us M. What about the next one? 2 plus D. Well, 2 plus D is 2 plus 3. That's 5. But the greatest common factor of 5 and C, 9, both of those, well, 5 is a prime number, so its only factors are 5 in itself. That's not a factor of 9. The only number that divides evenly into these two is 1. That's not 3, so this guy's out. How about C times D? C times D is 27. The greatest common factor of 27 and 9 is 9. Because 9 divides into 27, you get 3. It also divides into itself. 3 is a factor, but it's not the greatest common factor. That means that this is out. How about 2D? 2 times D is 2 times 3. That's 6. What is the greatest common factor of 6 and 9? Actually, it's 3. That means that this answer is a possibility, and we may need to run through this again with a different set of numbers. That's okay. It happens sometimes. But we can still eliminate some answers. We know we don't need to come back to B or C again, rather. Let's see what D squared gets us. D squared is 3 times 3. That's 9. The greatest common factor of this number 9 and our number 9 is, of course, 9. So this one is out. So although we need to run through this again, the good news is we don't need to check all 3 conditions. We only need to check these 2. Let's erase everything and start over with a new set of numbers. And we'll just have to make sure that we don't pick 0 or 1 because they behave a little strangely on problems like this, and we got to pick numbers that are easy to work with. How about instead now we use C equals 4 and D equals 2. Again, they are positive integers. M will be 2. Let's see what we get from these 2 remaining possibilities and if they work. Let's erase these 2. They no longer apply. Now, C plus D is 6. So how about the situation now? What is the greatest common factor of 6 and the new version of C, which I must point out is no longer 9, it is now 4. The greatest common factor of 6 and 4 is 2, which is equal to M, so this is still a possibility. How about 2D? 2 times D is 2 times 2. This is 4. Now, what is the greatest common factor of this number 4 and our C now, which is also 4? And the answer is 4, which is not 2, which is not M. Therefore, this is out for the second time around, and the answer is going to be A. Don't get me wrong. This is definitely something that could take a few tries, 3, 4 maybe. Okay? There's a little bit of luck involved here. But do it as quickly as you can. You don't have to write everything out like I did, right? You can do some of this in your head if you get kind of good at it. And each of the attempts can go a little bit quicker than the one before as long as you stay organized and you stay confident. Okay? We did this in 2 attempts. I think that was actually pretty lucky. I would expect that this might take 3 or 4 at least. All right, but keep plugging away at it. Do it as quickly as you can, and you'll conquer these kinds of problems on the GRE.